1. Welcome back. So once again, I've got Vivian here that's going to pretend to not know all the answers, hopefully, as we go through this. So to warm up, I'm looking for the range of sine squared x plus cosine x plus 1. So first, what does range mean?
It's the value of the possible y. It's the value of your y.
Okay, so the range are the possible values of y. So when we're talking about a range, we're really looking for an interval. The range is the interval of possible y values. So I'm looking for the maximum and the minimum. How do I find the absolute maximum and absolute minimum of a function?
Okay, in order to find the maximum and the absolute minimum value, I need to find the derivative of the function. And then I'm going to find out the critical point.
Sounds good. Okay, so I've got my original function here. What happens if I derive this function?
Okay. I will use power rule.
Okay, this is not a polynomial. So what's going to happen if I derive sine of x squared?
Okay, so that will become 2 sine 2 cosine x squared.
Okay, so it's
No,
I've got
it's just
something squared, so I'm going to have 2 times something to the first power, times what?
times the derivative
Okay,
of the sine x, which is cosine. So cosine.
I'm outside my equation. There we go. Okay. Plus, what happens if I derive cosine?
So if I have to derive cosine, I will have negative sine x.
Okay, negative sine of x. That was plus a negative sign, so it has changed to a negative. What happens if I derive 1?
Alright, so that will become 0.
Alright, so that's going to go away. Okay, so I've got this now. My derivative is equal to 2 sine x cosine x minus sine x. Is there any way that I could simplify this?
Yes, I'll take the common. I have a common greatest common factor. So
Right.
it's a sine x. So I have to take 0 sine x is 2 cosine x minus 1.
Okay. So to find absolute minimums or maximums, I need to find the relative minimums or maximums first and test the start point and end point of an interval. We don't have a start point end point of an interval, so we're just looking for minimums and maximums that we can find here for relative minimums and maximums. So I set this equal to 0 and we solve for x. So that means we can split this up into 2 separate functions now. So let me go ahead and do that. Our 2 separate functions are 0 is equal to the sine of x.
Okay, so I will take the inverse of sine for that.
Right. Okay, so for the left side, you said we're going to take the inverse. So this is x is equal to what?
Sine to the negative 1.
Okay, the inverse sine of 0. Where is the sign equal to 0?
It's in 2 pi or in 0 as well.
Okay, the
X
sign
is
is equal to
0.
0 at 0, or where else?
2 pi.
Okay, 2 pi. What about just pi?
180. So my y is equal to, yes. My y is also equal to 0.
Okay, so 0, 180, 360. So I've got 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. What's the pattern?
Yeah, every
Every pi
time.
units, we're going to be 0 again. So I could say something like this. 0 plus pi n, where n is any real number. So that'll allow me to go backwards or forwards, but every time that we are pi units away, we're going to hit another place where this angle is equal to 0, right? Okay, so that's a general form that will hit all the points that will make this equal to 0. And then what about this right side?
All right, so I need to solve for cosine x or inverse. So I can rewrite it first by 1/2 cosine x, and then I need to find the inverse of, so the x is equal to the inverse of cosine to the 1/2.
Put that in parentheses, but you're right.
And
So
then
where is the cosine equal to 1/2?
cosine is equal to 1/2 is square root of 2/2. So that is of 60 in pi over 3, 60 degrees.
Okay, I'm not sure what the root 2 over 2 was, but pi over 3 is right. So the
Yeah,
um, so the cosine is 1/2 at pi thirds, which is 60 degrees, but it's also positive 1/2 at one more point. So I'm looking for the same x value will give me one more angle.
Okay. I have pi over 3. Oh, no, 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 no. Uh, 5 pi over 3.
Perfect. 5 pi thirds?
Yeah.
Unfortunately, this pattern isn't as clean as the last one,
Yeah.
because the space in between them is not always constant. So I could do something like this. X equals pi thirds plus 2 pi n, or x equals 5 pi thirds plus 2 pi n.
Oh.
Okay. Trouble with the program there, but so because if I spin 2 pi, I'll end up at a coterminal angle, right? I'll end up at the same place. So all the angles that are coterminal with pi thirds and 5 pi thirds, I can add 2 pi to both of those, and I'll end up at the same place. Okay, so that gives us really 3 points that I need to test to see what's the maximum and minimums for these intervals. So if I plug in 0 into my original function, what's going to happen?
Okay, so it will become 0.
Okay, the sign at 0 is 0. What else?
Okay. You want me to include
I'm plugging in 0 into my original function to figure out what the y value is at this point.
okay, if I have 1, if my n is 1, I have 5.
So these n's can be anything, so I'm going to say n is 0, so that means x is 0. If I plug in x equals 0 into my original equation, then this becomes, let me copy this one down so I can get this all on one screen. This becomes this. Okay, so if I plug in 0 for x, what's going to happen?
Okay, I need to check.
Okay, what's the sign at 0?
Sign at 0
Is 0. So I've got 0 squared plus, what's the cosine at 0? 1 plus 1. So what's my function at 0? Okay, then I'm going to do my next point at pi thirds. So this is my function at pi thirds is equal to, what is the sign at pi thirds?
Okay. Sine at pi thirds is equal to okay. That is square root of square root of 3/2.
Perfect. Root 3 over 2, and that was squared, so that's the sign at pi thirds squared is root 3 over 2 squared. Okay, I'll get back to that in a second. Plus, what's the cosine at pi thirds?
1/2.
1/2? Plus 1. Okay, so I'm going to add all this together. Kind of cheated last time, it didn't work vertically, so let me backtrack a minute, I'll put that in. Okay, so my function at pi thirds is equal to, what happens if I square root 3 over 2?
Okay, that will become 3/4.
3/4. Plus, I'm going to make all of these into fourths. So 3/4 plus
Okay,
2/4 plus 4/4.
4/4.
Okay?
That will give me 10/4.
Will give me, say again? 9/4. Okay, cool. 9/4. Okay, and we've got one more point to test at 5 pi thirds. Okay. If I plug in 5 pi thirds into our equation here for sine, what is the sign at 5 pi thirds?
That is square root of 3/2.
Okay, it's a y value though, so it's negative, so negative root 3 over 2. And then I'm going to square it. Plus, what's the cosine at 5 pi thirds?
It's negative 1/2. Oh, positive 1/2.
Positive
Oh, no,
1/2, because our x value is going to be positive on that side, but our y value will be negative. If I draw that out really quick, this is my unit circle. Okay, so if I split this up into thirds, it would look something like this. So thirds, okay, where this is 0 pi thirds, pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds is what we're looking for. Okay, at 5 pi thirds I've got a long side and a short side. My longer side is this line in blue, and then my shorter side is this side in green. So my short side should be positive because I'm in this quadrant, and then my long side will be negative. My y value is going down, but my x value is going to the right, right? Okay, anytime I have a long side and a short side on the unit circle, my short side is 1/2, my long side is root 3 over 2. Okay, so this is positive 1/2 plus 1, which is going to end up giving me the same value. I've already squared all of this, so I've got 3/4 plus 2/4 plus 4/4 is equal to 9/4. Okay. Now it looks like we're done, but we're not quite. We're actually missing one value that we need to test. Do you have any idea what we're missing?
I get the 0 and
I'm going to scroll back up to our answers here. We tested 0, we tested pi thirds, we tested 5 pi thirds. What else do you think we need to test?
the pi n.
The pi n part, right. So for all of these, we're plugging in 2 pi n is going to end up giving us the same angle. So I don't need to test another value for this pi thirds or for 5 pi thirds, because it'll give us the same angle. But for 0 and pi, those are different angles. So I do need to test pi as well. The reason why it matters is because I don't just have sines in my function, I also have a cosine. And for cosine, that value will be different at pi than it is at 0. So I also need to test my function at pi. Okay, so let's plug that in too. My function at pi is equal to, I've got, what's the sine at pi?
Oh, the sine of pi is 0.
0, so that's 0 squared. Plus what's the cosine at pi?
It's negative 1.
Negative 1. Oops. I'm going to say minus 1. Okay, plus 1 is equal to 0. Okay, so let me highlight all of the final y values that we got here in red, because I've got a lot going on at the moment. These are all of our relative minimums or maximums. So these are all the points where our function is going to change direction. Ah, okay. Since our function's continuous, these are the only points that could be absolute minimums or absolute maximums. Okay, what is the biggest y value that we found?
Let's say 9/4.
9/4, right. So I had absolute maximums at pi thirds and 5 pi thirds, which gave me a y value of 9/4. And what was our smallest value?
The smallest value is
0. So what is the range of our function?
0. So the range is y is bigger than 0, but less than 9/4.
Okay. So in interval notation, how could I write that?
The parenthesis.
Parentheses
no.
means not included.
Okay, so you have the brace.
Brace.
The
Okay.
brace is 0. 0 and 9/4.
9/4. Perfect. Let's see. I do need to make this an equation so I can get this in the same format as the others, but that's perfect. Yeah. Okay, maybe I have to rewrite this. My range is from 0 to 9/4. Okay. Let's get rid of this line. And that gives us some room. Any questions on what we did? Okay, I'm going to overview really quick. We wanted the range of possible y values of this function. Because the range is all the possible y values, I can look for the absolute minimum and maximum of our function. Now there's no discontinuities for our function. Otherwise I would have to do this for every interval that we have discontinuities for. And I'd also need to test the start point and end points of any interval if you're splitting up your function at all. So because this is continuous, I could just take the derivative, set it equal to 0, and solve for x. That gave me relative minimums and relative maximums. Now I didn't test around these points because we really don't care what they are. As long as they are a critical point, as long as they are a point where our function changes direction, they could be the absolute maximum or minimum. So those are just these are all of the points that I need to test. Now it looks like there's only 3 of them, but really there's 4 because this point at 0 and at pi is going to be different in our function for the cosine. You notice this one I'm adding half a rotation, pi, whereas these ones I'm adding a full rotation, 2 pi. So if I'm adding a full rotation, these angles are not going to change my final answer. But if I'm adding half a rotation, this one potentially can. So we tested 0, pi thirds, 5 pi thirds, and pi, which were our 4 values on one full rotation. That would cause our first derivative to equal 0. So that means that would give us a horizontal tangency to our function. And then we looked for which of those y values, when I plug it back into the original function, would give me the largest possible value and the smallest possible value. The one that gave me the largest was my absolute maximum, and the one that gave me the smallest was the absolute minimum, and my range has to be between the largest and smallest. Alright, awesome.